audible?
Madam, you may proceed.
Okay, sir. Thank you.
Yes,
Good
yes, you
afternoon,
are.
everyone. I'm Dr. Lavanya, working as assistant professor in School of Management Studies, CPIT. We resume to our AICTE Training and Learning 6-day FTP, session 12 on Advanced Automation and AI for Lean Manufacturing. It is truly an honor to introduce our esteemed guest speaker for this session, Dr. Hussain Shiraji. Dr. Hussain Shiraji is an assistant professor of Management Information System at the Flower College of Business, San Diego State University. His research centers around trustworthy AI, focusing on efficient, secure, and fair AI applications across cybersecurity, distributed intelligence, and healthcare. Dr. Shiraja's work on model compression and federated learning enables collaborative intelligence with data privacy, addressing challenges in phishing detection, the Internet of Things, and industrial security, and anomaly detection in complex networks. His neural language processing driven research tackles misinformation detection on social media, particularly in public health context. Sir has got 22 years of experience in this field. So without any further delay, I now hand over the session. Before that, we welcome you, sir, on behalf of our college to this wonderful FTP. We look forward for your experience sharing. Over to you, sir.
Hello, everyone. Can you hear me?
Yes, sir, you're audible, sir.
Oh, okay, great. Thank you so much. Do you want me to share my video as well? Can you see my video now?
So just now we given you as a presenter. Can you please go through and share PPT?
Okay. Just give me a second. So,
Sir, it was seen earlier.
okay.
Yeah, now it
Okay,
is
great. Can you see my screen?
Yes, sir.
Okay. Do you want me to start, or just do you want me to wait 2 more minutes?
Participants are already in the call, sir. You can please proceed.
Okay, great. Thank you so much.
Thank you.
Hello, everyone, and I hope you are all doing good. I believe that's an afternoon in India. However, it's early morning here at San Diego, and it's 2 a.m. So sorry if my voice might not be as loud as usually I'm in the morning. So but it's really an honor to be here with you all at this time, and thank you so much for inviting me. I'm Dr. Hussain Shirazi. Thank you so much for the introduction, but I'm Dr. Hussain Shirazi. I'm an assistant professor at San Diego State University, and my research area is on trustworthy AI, and I worked on multiple cybersecurity problems, including phishing detection, security of IoT devices, and misinformation detection in social media. More specifically, if I want to talk about social media, I worked a lot on misinformation detection. And today I want to talk a little bit about what I've done as misinformation detection, how we can challenge and find misinformation that might be propagated in social media. For today's presentation, I want to present an overview of a few papers that we have published in this area, and the title is Seeing Should Probably Not Be Believing, the Rule of Deceptive Supports in COVID-19 Misinformation on Twitter. This work has been done with a group of researchers from San Diego State University, Colorado State University, and Stony Brook University, with my other colleagues and PhD students and graduate and undergraduate students. However, I'm presenting this work on their behalf. So, before I want to explain the details of this work, I want to explain the importance of the problem of misinformation detection by itself. The problem of misinformation detection is a super important problem, especially with the expand of social media. However, what we are presenting, it's just a case study. COVID-19 and propagating misinformation is a case study that we studied on this domain. However, many of the techniques that we have used, many of the approaches that we have used, it's quite relevant to other area. If you are interested to study this problem on different domain, uh, it's quite relevant to use the very same technique, and the COVID-19 might be quite old this day. However, the reason that we emphasize on the problem of the COVID-19 is because the COVID era was a very significant the problem at its time, and as well as a very good use case to show how this misinformation could be propagated on social media and how we can use advanced machine learning / deep learning / NLP techniques to fight against this problem. And nevertheless, it's a case study. However, if you learn this technique or learn how we have challenge this problem, it's quite relevant to other domains, so you can use this technique. So the problem motivations during the COVID-19 pandemic, it was the first time of experiencing an infodemic alongside a pandemic. The amount of information that's propagated in the social media was something that the human beings has never been experienced before, and fake news was a significant problem that influences the people behavior and alter the effectiveness of the effectiveness of the countermeasure deployed by the government. So detecting fake news was still is a significant problem, and but if you want to narrow down the problem and look at what types of misinformation that we were looking at, might be interesting because not all of them are the same case. For example, we had the clickbait, the websites that the clickbait uses exaggerated, misleading, or emotionally charged headlines to attract attention and ask for the click on of the websites. The wrong URLs are another type of techniques that being used here that trick user by mimicking real website and leading them to deceptive or malicious website. However, we are seeing a very specific type of deceptive citations. That means adding a link to an irrelevant article from a reputable news agency. This is something that we specifically focused on, and I want to explain a little more about this type of misinformation. In this case, we were seeing adding a hyperlink or link to a well-known news source, but in a very misleading way that creates false credibility. What do I mean by that? The people, and this is still a very well-known problem, that the people use a link from a reputable source to imply that it supports the statement that they are putting on their social media, even though it's not, even it doesn't do that. The broken logic here means that the cited article or the news that's referring to may be completely unrelated or completely irrelevant to the claim that they were mentioning in their social media post. So, however, because if the people are sharing this information on their social media, the reader assumes that the claim is valid simply because the source is reputable and they are seeing on the feed or on the post that is coming from the trusted circles like the friend or colleagues. An example here could be a blog post claims that the Harvard scientists confirmed alien life. However, and there's a link to, for example, New York Times article about new space telescope discoveries. However, there is no mention of extraterrestrial life. So why this is dangerous? Because this practice can mislead audiences and spread misinformation and erode trust in legitimate journalism. So this is a very specific type of problem that we studied in this project. So what I want to emphasize that instead of instead of solving a very big problem that might be quite challenging, we narrow down it to a very specific type of misinformation. And as I can say, it's adding a link to an irrelevant article from a reputable news agency. So here on the left, on the right side, you can see a tweet that we collected at that time. The tweet says, Italy coronavirus, Italian who attempt to flee lockdown may face jail. And it was a CNN. And on the downside, you can see an article from CNN, which is a reputable news agency. However, the article never talks about such things. So in the problem motivation, we want to say the tweet itself is check-worthy, meaning that it works to check the tweet. However, it's the claim in the tweet itself. It's not supported by the news article. So that's a very specific type of misinformation that we want to discover. Uh, if I want to talk a little bit about the problem statement here, is the fake news detection is the prediction of the chance of a particular piece of information being intentionally or accidentally deceptive or right. Having said that, we can define three types of fake news: the misinformation or the false information or honest mistakes not created with the intention of causing harm. Disinformation is false information deliberately created to harm a person, social group, organizations, or country. And last one, malinformation, are the right information based on reality, but in the wrong context, used to inflict harm a person, organization, or country. So this is the three types of information, the fake news that we can face, but we are focusing on misinformation, meaning here we can have we can see two or three example of this misinformation. For example, spreading the virus through bat and pangolin, that we've heard about it during the pandemic era, or several celebrities, including Cristiano Ronaldo, tested as corona positive. And the last one, which was very famous and oftentimes I use an example, is that the lemon and garlic can cure COVID-19, which we all know that these are not true and true information. So in the stage of reacting to a disaster like COVID-19, four crucial stages are happening: prevention, preparedness, response, and recovery. So, however, in this case, what we wanted to focus is on the prevention. What do I mean by that? Because when the misinformation might propagate on social media, there are different stages that you can detect disinformation. Uh, for example, many of the study focused on detecting this misinformation after this information has been propagated and by looking at the network of sharing. However, we believe that this stage it might be too late to detect misinformation. So what we have done is we are looking at the information that we are seeing or the claims that we are seeing on the social media network and try to detect them as early as possible in the prevention stage. So that helps us to reduce the damages and the proper uh, and stop them at the earliest stage and to a risk the risk management and at this stage. Going forward, the problem statement here was for each COVID-19 related post on Twitter, we still call it as a Twitter. We know that the name has been changed to X, but uh, the, I used to use this name. So for each COVID-19 related post that cites a news article, we want to know that does this post contain an objective claim and is that claim important enough to verify its validity? That was our first question, because not all of the not all of the tweets that we see on the social media are checkworthy or important enough to verify its validity. And the other side, based on the type of misinformation that we define, not all of the tweets are referring to a news agent, news. And the second question was, does the cited news article support the claim in the post or not? These are the two main questions that we want to answer in this study. So, and we created the whole study based on these two questions. If we're able to answer that does this post contain an objective claim, and is that claim important enough to verify its validity, help us to filter the amount of data that we are focusing on. And the second one, we can see and make sure that if a claim in the tweet is being supported by the news article that was cited or not. So having said that, natural language processes is a computer techniques or set of computer techniques that can make the computers understand and process human languages, whether in the form of the text or audios. There are many applications like speech recognition or natural language generation or named entity recognitions. However, what we focused are here is a text classification. That's a very specific part that we have done. But going forward, the approaches that are available, there are rule-based techniques, machine learning, and deep learning. And these days, in the era of the ChatGPT, deep learning was the technique that being used. So for the evolution of the natural language process, we've seen very different algorithms developed over times, like one-hot encoders or TF-IDF vectorizations or bag of the words. However, our focus was on the advanced techniques of transformers, or the algorithm was that we have used. But what we have done was using the BERT or pre-trained language representation models. That the way that it works is these algorithms, the specific algorithms like BERT here, are trained on a significant amount of data, like the book corpus and English Wikipedia, and that helps us that gives us a representation of the words and sentences that we can see, and that's very useful to understand or comprehend the text, and then we can use the power of these techniques to see what claims do we have in our text and classify the tweets. Going forward, these algorithms are trained or developed on different machine learning tasks, but the two very famous ones are the next sentence prediction or the masked language modeling. But I don't want to go to the detail of these models. I'm pretty sure that you might be familiar, but we created our work on top of these or use these language models. So let's talk about what we have specifically done this in this series of work. So on the left side, on this figure, you can see the architecture or systems. We started with collecting a significant amount of data from Twitter network. Sorry. Then we filtered the data And then the stages that we had, we filtered the data and then we cleaned up the data. And we defined two tasks of retaining the checkworthy tweets and the classifying the tweets as misinformation or authentics. However, we used some other references like articles from news agencies that we have collected. And in our collected news articles, we use these news articles and split the articles to the sentences to be checked whether the sentence are supporting the claims or not. And I will go over the detail of these, some of the details of these steps. So during over almost 2 years during the pandemic, we have extracted or collected a significant amount of data related to the COVID-19. We collected more than 400 million tweets during the pandemic, and we created one of the very largest data set. And one of the good thing is, because we collected the data during the pandemic itself, we had access to many of authentic data, and some of the data that we collected are not available anymore because the tweet might have been deleted, or simply the accounts are not available, or things like that. So we had access a very large set of data that we collected during the pandemic. So, and on the right side, you can see some numbers related to the tweets, and you can see on average, we collected more than 1 million tweets per day. Next step was our data filtering, and the reason that this step was super important to us was it was not possible to analyze all of this data, so we had to filter the data and do a lot of data cleaning. So for the data cleaning steps, what we have done for the for the data collection part was we started with a set of keywords and used the Twitter API to collect the data. However, we found out that in many cases the tweets are not relative to the keywords that we defined, or the tweets may not be simply related to the COVID-19, and the tweets may not have a link to news articles. So based on the type of misinformation problem that we defined, we thought that if the tweet is not linked to news article, we can simply skip it. We have done a lot of data cleaning step, like replacing the slangs and abbreviations, which is super important because if you in Twitter, due to the character limitations, there's a lot of slang and abbreviation being used. So we replaced many of them to help our NLP algorithm understand the text better. We replace the emojis or remove non words character, like the URLs and things like that. And finally, we have done a lot of data deduplication, making sure that we are not checking the duplicated data, or the tweet might be duplicated in our data set. So the first task, or the first question, the research question that we had here was to making sure the claim in many tweets cannot be considered fake or true information. What do I mean by that? In many cases, the tweet may not contain any information. So just simply might be the thought of the people or the opinion. So what we have done here at the first stage, we created a supervised binary classification algorithm that decide whether the tweet is containing any information or important information or not. So what we have done was adding a classification layer on top of a transformer-based model. And we fine-tuned the model on relevant data set that we were able to collect. For that purpose, we collected two existing data sets. So each of which has some checkworthy data and non-checkworthy data. We also created our own data set. We manually label 100 tweets based on if the tweets are checkworthy or not. So we had three sources of data or three sources of labeled data saying if the tweets or if the data that we are seeing are check-worthy, meaning that it has some information that needs to be validated or not. So with this three data set, we created our our algorithms, and we used 10 different general purpose NLP algorithms like BERT model, different groups of or different families of BERT transformer, and we fine-tune these models on our different combination of the data set that we had. And that and this step helped us to evaluate the performance of the model on some trained data and see if the model is working good or not. Next, the second part was that's related to the second research question, and the hypothesis here was a claim should have some semantic similarity to its supporting evidence, meaning that here the news article that we are referring to. So after filtering after the first step that we filtered the data that has actual some information, some check-worthy information. Now we want to know if that piece of information is being supported by news articles. So here we have split the news article in two parts, looking only at the title of the news article or the body of the news article. And then here again, we created another binary classification algorithm to do this checking. So here is another flow chart explaining how we have done this step. So the tweets or the tweets that are first check-worthy factual claims and has a link to news article which appears to support the presented claim are collected. So, and then we, at the first step, we check the news headline to see if the news headline by itself is supporting the claim in the tweet or not. If the news headline was if the news headline was supportive, so we could simply assume that the claim is supported by the cited news. However, if the headline by itself was not enough, we go to the next step and we looked at the body of the news article, and then if the body of the news article also supportive, we do the same decision. However, if the body of the news article doesn't support, finally we can assume that the news or the cited news falsely appears to support the claim. And we can, at this stage, we can assume this tweet is misleading as propagating misinformation. Okay, so just want to make sure that you can hear me, because I'm not getting any feedback from you. So can you hear me?
Sorry,
Yes,
sir.
sir, we are hearing you.
Sorry,
You
sir.
proceed.
Sorry, you can proceed.
Oh, okay. Can you hear me? Should I continue? Just want
Yes,
to
sir,
check
please
basically.
continue. Please
Okay,
continue.
okay, great. Okay. So the one thing that we had to, and that one thing that we had to at that time was removing the tweets that consist of multiple sentences due to the limitation of the algorithm that we were using. I know that these days that may not be a problem anymore. However, due to the limitation of the algorithm or the algorithm and transformer model that we're using, that was a big limitation. So we had to, some cases, remove the tweets with multiple sentences or multiple claims, and that was a part of limitation in our the whole works. I believe these days this is not a limitation anymore with new advanced technique that can contain or can use larger context to analyze data. So for this step, for our second questions, again, we didn't have any labeled data set, so we didn't have any a set of data that the tweet with the news articles are together paired and could be used for the training purposes. So what we did here, we came up with an idea of uh, like silver standard training data set. So there was no gold standard training data set, meaning that there was no manually labeled data set in that time. So what we came up was we used the idea of distant supervision learning algorithm, meaning that we can use a large amount of noisy data, which are weakly labeled training, and use that concept for training our model. And what we have done here was we created some negative samples, which means we randomly pair tweets a news article, assuming that these two a random news article being assigned to a tweet, these two are not related to each other. So these are our negative samples. These should not be considered as a true association. So we can label this one as a negative samples. On the other side, for our positive samples, we assume that the tweets are paired with the news article are uh, actually true associations. The tweets that we already collected in our data set. So these are the positive samples that we can assume. However, there's a chance that some of the misinformation that we have in our data set could be labeled as positive samples. However, this is something that we know. That's why we call it as a weakly labeled training data set. So that's a technique that that has worked pretty well to solve the problem of not having a labeled or gold standard training set for this step. So going forward, we have done two things. For the first step or headline checking, we use four different algorithms: our BERT, city BERT, which was a specific BERT model that was trained on COVID-19 related tweets, XLNet, and Roberta. And for in the second phase, or the checking the body of the news, we use Distill Roberta, Longformer, and all four other models that you saw on the slide. So the four other models also were used. So uh, now let's talk about information verification on phase one. We found out that for 54% of the tweets repeat the headline with minor modifications. What does that mean? It means that the many people simply used something very similar to the news headline in their tweets. So what we have done here with pairing the classification layer on top of the methods, we were able to detect this similarity and label them as trustworthy, because there was no difference between the tweet and the news headline article. So that could simply solve the problem. The next step, we have done some technique to split the news article into multiple sentences and paragraph, and then we go over all those paragraphs and try to find at least one paragraph or one sentence that support the claim. Even if we can only find one sentence or paragraph that supports the news the claim, that was a positive label, meaning that these are related. Otherwise, we could label them as misinformation. So in this step, we're going over all sentences and trying to see if we can find the supportive step. So let's talk about a little bit about the results. For our first step, XLNet model, gave us a very good fun score of 76. So we use this one as a filtering mechanisms that can find out check-worthy tweet for us. So we while we collected a significant amount of data, we have done we used a smaller set for our in our experiments, and we find out that on the validation set that we have done, both headline levels, 98% or all models are giving us a good showing us that the results the, the claims that we have in the tweets are similar, are aligned with the news headlines. And in 5,000 samples, we find that in a set of 5,000 samples, we find out that 258 pairs of tweet and news headlines are false negative, meaning that the model predicts the claim to be unsupported by the model. So these are the potential cases that might be deceptive. However, you have to check the news article. But in the next step, when we looked at all these samples, we find out that 51 tweets are not checkworthy. That was something kind of not important. However, at the end, we were able to find out 55 tweets in a set of 200 samples as misinformation, meaning that we've even in a small set that we manually annotated them, we find out 55 tweets are misinformation, meaning that the claim in the tweets are not being supported by either the title or the body of the news article. So that was a very big step for us, because almost 1% of the tweets that we have collected was misinformation. We were able to automate this process. However, we didn't stop at this stage, so we go even forward, and we went beyond the misinformation. So the next step, we focused on the influential users, or how we can call them as influencers. We know that the influencers, or the people who are having a large number of followers or verified users, are having more effect on the public discourse. So we want to see how these people might affect general audiences, and how they prepare the message that we want to deliver to their public audiences. So more specifically, we want to know what different types of influencer or influencer users do we have. We categorize this group of influencers between two groups of individual users, the people who are individual influencers, like for example, United States presidents or UK prime ministers. However, at the same time, we had a lot of organizational users, like WHO or CDC as an organization, or many newspaper agencies with their official organizational account. So the questions, or the research questions that we want to study here, was how do individuals and organizations express their opinion and communicate their perspective about the COVID-19 on Twitter, and what are the differences. The core here is to understand when the people are talking, or more specifically, when the influencers, users on Twitter, when they're talking, when those are individuals versus organizational users. What's the difference between their messages that they are sending? So more specifically, we want to know to what extent deep learning algorithms can effectively profile individuals and organizations' accounts on social media. To study these differences, we came up with three metrics. So, emotional appeal they use, overall sentiment they use, and last one, the degree to which they rely on scientific evidences in their post. So if we can look at the tweets and the data that they are posting based on these three parameters, we might be identify and categorize on the influence of these people based on their individuals or organizations, and we can characterize these users better. Going forward, the dimensions, these are the three dimensions that we study. The emotions that reveal subjective perspective of these users, the sentiments that uncovers the prevailing attitudes influencing information spread, and the scientific claims that aid in identifying misinformation. So these are the three aspects or dimensions that we analyzed, and only on influencer accounts. So the methodology that we used here, we started with detecting if whether a user is individual or organizational, and then we had the multifaceted labels capturing that captures the emotion, sentiment, and scientific claims. For the emotions, we labeled the emotions onto 5 labels of the happiness, sad, fear, anger, and surprise. So we used 5 different labels for the human emotions. For the sentiment analysis, we focused on the 3 famous labels of the positive, negative, and neutral. And finally, for the scientific claim identification, we had 3 labels of scientifically verifiable claims, meaning that these claims are scientific claims that could be verified. The second label was scientific knowledge references. That means these are referring to some knowledge. And the last one was general scientific research, meaning that these are general scientific research. These are the 3 different categories that we had, and we got this idea from another paper that we cited in our paper. So in our methodology here, we use the same data set, and also we at this time we were able to have access to the much larger or stronger algorithm comparison to the previous work that we have done. So at this time we use large language model like the GPT models and the few shot learning technique that we have done. So here you can see another the workflow that what we have done. So we started with collecting data from Twitters. Actually, we used a lot of the data that we collected in the previous steps, and then we used we developed 4 different algorithms, each of which was responsible to label one aspect of or one dimensions: the user profiling, emotion detection, sentiment analysis, and scientific claim verification. So we have 4 different algorithms developed for each of these tasks. So we also, similar to the previous steps, we had very similar data pre-processing that started with removing the emojis and hashtags and cleaning up the data and things like that. And finally, we had a very classical classifier classification algorithms that was trained out on data. So for the user profiling, that was the kind of the very simplest task that we were able to we were able to detect individual from organizational accounts with a very high accuracy. And the models that the topic modeling that we've done on top of this one. So we found that individuals are political, entertainment-oriented themes. These are these are the influencers that we had in our data set, and organizational are like commercial or sports-related themes. We didn't stop at this stage, and we then tried to find, look at the deeper analysis of our data that we collected. And these are some topics that are associated with the with with the individual influencer in our data set, as well as the organizational. Like for the organizational, like we had marketing or business technologies, or football or club leagues, groups of people. For the emotion and sentiment analysis, what we have done, again, we use the same algorithm and then try to see how organizational accounts are different from individual users. And as you can see here on the right side, we observed a lot of interesting the pattern here. For example, as you can see in this blue color or lighter color, you can see in individual users, the angry emotions were used much more than the organizational account, as well as the joy. Or in general, individual influencers or accounts expressed more emotions or more emotion in their tweets. So that's one observation that we made. Next one was related to individual and organization sentiment analysis. What do we mean by that? It means are they using what's the sentiment that they used on their tweets? And as you can see, here we selected 5 subtopics related to the COVID, like vaccine, travel, face mask, and work from home. And as you can see, in all cases, individuals from organizational accounts were used a much more neutral language when they were talking about these topics. However, on the other side, individual users are having a much more clear sentiments in these topics. For either they are more negative or more positive, based on their based on the topic or things like that. However, it clearly shows that the individuals are more polarized, meaning that they are explicitly are in favor of or against something. They less have a neutral sentiments. Finally, for the scientific claim verification, we used a Cybert model, which is trained. It's a very famous model that is trained on these data. So we were able to again, we looked at our 5 subtopic categories, and we were able to see how individuals versus organizations are using 3 groups of the categories that we discussed are verifiable claims, references to scientific sources, and general categories. So we were able to do this one, and in all cases, we saw that on average, the individuals are using less verifiable claims in comparison to the organizational, and that was another observation that we saw in our experiments. Going forward, GPT 3.5 models, GPT 3.5 showcase an impressive performance on emotion analysis. And Roberta performed better on the sentiment analysis, and the Cybert demonstrates better on the scientific claims. The Cybert was, and we were not surprised because the Cybert was created for that purpose. So that was not something that that was something that we were expecting. Uh, in conclusion, we wanted to focus on the data set of the COVID-19 related posts on the social media, and we were able to filter non-check worthy tweets. In our filtering algorithms, we were able to reduce half of the size of data that was very helpful to scale up the whole process, especially when you are working with a very large data set. As I showed you, we were dealing with 400, 500 millions of tweets. So regarding the information verification, we find that at least 1% of the tweets are not supported by the link that they are using, meaning that these tweets might be considered as misinformation. For the user profiling, we find out the individual users are more polarized sentiment than the organizational users. We might assume this one, but we were able to systematically show this one through our analysis and study. Finally, we proposed a pipeline to identify a specific type of misinformation in Twitter, and that this specific pipeline has a few important mechanisms like the data filtering that helped us to scale up the whole process, and uh, using the lightweight algorithm that that are freely available to other researchers to proceed with this type of things. In the future, and these are some of the things that we are working, we want to improve the performances on some cases and enhance the real-time monitoring system that can detect these type of threats at the earliest stages, and have an implemented algorithm that can detect such misinformation at the very early stages. Thank you so much. Thank you so much, and I would be happy to answer your questions. I'm gonna stop sharing my screen and just come back to the audiences. I hope you enjoyed this presentation, and I would be very happy to answer your questions.
Dear participants, if you have any questions to post, please you can type it in the chat box, or you can unmute and please ask the questions.
Should I even see? Thank you. Okay, so if you have any question, you can post in the chat. Also.
Sir, I have one question.
Oh, sure,
Like
please.
from the present, like when you were discussing about the methodology. So you've mentioned about the large language models. Can you please elaborate what are the different language models available? Like you were
You mean the
discussing about customized transfer models, few short learnings, and then you were mentioning about large language models. Like in example, like I feel like you were talking about GPT 3.5.
Yes. So that's a very good question. So what we let me just explain a little more details on what we have done here. The time that we started this project, it was about 2022, and at that time, many of these large language models that are available to us were not available. So we started with some like BERT models and the family of BERT models. However, in 2023, when we were doing the second stage of our work, some of the large language models were accessible to us, like GPT 3.5. So we used GPT 3.5 through the APIs that we had. However, if you want to use such models, there are much more open source available models like Llama 3 or Deepfake. These are freely available to you, and there are other models and like Mistral is another very good model that is available, freely open sourced through API. But we're just downloading the models. Also, at the same time, there are cloud-based services that if you pay some, the small amount of money, you can have access to the other models like GPT models, the family of GPT models. But what we used was here is a GPT 3.5.
Okay, thank you, sir. Sir, if you permit, I have one more question.
Of course, please.
So when you were mentioning about the future work, like we here have MBA graduates and we offer them business analytics as an elective. So they don't have a deeper understanding or kind of a graduation from this particular domain. If they want to apply for these concepts for their research, so how can they begin with, sir? Because as you suggested, they can go for refined predictive models. So what is the source from which they can gain knowledge on existing models for using NLP or ML? How can they apply to the social sciences field?
I see. I see. That's a very good, that's a very good question, and actually, uh, I can explain. As I'm also in a business school, I have MBA students in my AI and cybersecurity classes, so I can explain this one to you a little more detail. So, uh, the situation is not comparable to, for example, 2 years ago. So these days, there are lots of good models are available easily, to all of the researchers, especially, the students like in MBA. So what I can suggest to your students is are a study. If they want to do a good job, so they can start with some basic of machine learning, deep learning techniques, just briefly, and then they can use a lot of free services like GPT models have the API, and they can develop their own systems in just few lines of code. Like in systems like using OpenAI's API or some other services. For example, Together.ai is another service that gives you API through, for example, a programming language like Python, that they can do a lot. So what your students can do is starting uh, doing the analysis with ChatGPT, which you don't need to write any coding for that. So with a small experiment that they can do on ChatGPT, then they can take that one to the programming languages like Python and do the deeper analysis on using the programming languages. So, and that's a very good practice these days that the students can do. And many of my students, from not very technical background, we started doing this and using the API and this large language model. They are able to run very sophisticated analysis on their data.
Thank you, sir, for your answer. I think if my students were part of this session, they would have got more insights directly interacting with you.
Oh,
Um,
sure.
yeah. Participants, any questions? You can please unmute and ask. Venkatramana, sir, are you available?
Yes, I'm here.
Madam. Yes, madam.
Yes. Yeah. Can you
Final
please
call to all the
check if there are?
participants. If you have any queries,
Yes.
please interact with our session speaker. I hope Sari is ready to answer all our questions. Please make use of this opportunity.
You also can type in the chat if you want. I have access to the chat, so I can read your question here as well.
Sir, there is one question in chat box. Please go through, sir.
Oh, I see. Yes. So let me. Oh, I see. No, thank you. Um, I see one questions. The Dr. Jayanti asking, how can NLP-based sentiment analysis be used to gauge MBA students' engagement with the learning material? So that's an interesting, the questions. The sentiment analysis is a quite well-studied, well-studied problem or well-studied task in the context of the NLP. So how I can answer is with the existing of with the existence of these large language models like the GPT, it's quite possible that you can use uh, you can use your students' feedback and their behavior to analyze it to see if they are engaged in the classes or not. So you can you need to start with the data that is available to you. For example, like for example, you can start with the assignments or the time that they spend and something like that to collect, and then use the existing service. There are many of the existing service or the MLS contents. This data could be collected from such services, uh, and then this could be used as part of your data for detecting the sentiment, I believe. So indeed you have to start from the data that is available to you. The submitted assignments could be one part, and then you can use that assignment as an input for your algorithm to see if you can detect yeah.
Sir, one question from my
More?
end.
Yeah. There's one more
Which is the
question, sir.
biggest,
Yes, sir. Please proceed.
which is the biggest challenge in implementing AI-driven lean manufacturing, sir?
Sorry, your voice was broken for a second. Can you?
Sir, can I repeat, sir?
Oh yes, please.
Which is the biggest challenge in implementing AI-driven lean manufacturing?
Oh, I see. So, you know, honestly, I'm not that much expert in this area, but what I can suggest, or what I can think about the problem is, for implementing any AI driven models. Currently, there are uh, two major challenges, and that applies to any areas, including the uh, lean manufacturing. The first of all is the computational power. So many of the current AI models are very computationally heavy. So finding a model that fits or meets the requirements that you might have in your industry is super important. That's one of the reasons that I myself studied, in addition to this misinformation detection. I'm currently studying on how we can uh, make the current AI models less more efficient and less computationally extensive. For example, there are a lot of technical compression technique or quantization that helps you to significantly reduce the amount of the computation that is needed. For example, I'm working on sort of the security of vehicles problem that we are trying to create some devices that could be installed in vehicles and detect cyber attacks against the vehicles. And the computation power is one of the biggest challenges that we are facing there. So one is the computation power that you can provide to a problem. So that's a big, or that's the biggest challenge is in any domain, most probably in that environment. That's another challenge. And the second one is the available data. While we have much more data than ever, there's still two big issues with the data. The first of the issue is the quality of the data. We have more data, but the quality is not that good. So you have to not only collect the data but also look for the quality data, which is very important. The second the issue is regarding the data is to make sure that the data is applicable to your models. Uh, these days, the good thing is, we have the models that are working with multimodality, meaning that you can, for example, combine time series data uh, as well as the time series, as well as, for example, images all at once. So that's another opportunity that you can use or benefit from different types of model in the same AI algorithms. But it's still, we have the issue of the collecting the data. So that was uh, that was my.
Sir, we have one more question in the chat box.
Oh,
Can AI and NLP be designed in such a way as to avoid bias and ensure fairness in the management students' learning experience? If yes, kindly explain how.
yeah. Thank you so much. That's these are very important questions, all super important, and many of them are still open questions that significant study are being done this one. So the fairness and bias is a significant issue in current AI. So due to a lot of training data limitations, any existing AI that we see these days are even small are biased. So that's the biggest one of the biggest challenges that we are facing. And not only these models are biased, but also it's very difficult to detect such biases. So the fairness and bias is not a solved problem yet, unfortunately. So that's something that in answer to that question, ask to how to create a model to avoid bias. My answer is we are not there yet. However, you can come up with some techniques and mechanisms to make sure to reduce the biases and making sure that your model is not significantly biased. So there are very well studied techniques, but you have to start from the types of bias or the type of or the groups or the goal of your study, and then if you are working with a specific group of students, for example, and you have a target groups, you need to study that specific group better and see if your model is biased towards them or not. So let me give you an examples to make it more clear. Let's say if you are in a situation that you have senior students uh, are in your class with, as well as the younger students, it's quite possible that your model is biased towards younger students because we have more data from the younger students. That might be the case. So by knowing this bias at the earliest stage, so you can control and see if your model, if your final output is biased or not. So you have to start with the information that you know about your target group. For example, the age might be something, and then if you aware of that one, then you can control it and make your model much better. So that's the general suggestion that we can make always.
Thank you, sir. One last question, sir. This from Venkatamna, sir. How to build a lean AI strategy? That was his question.
I see. So uh, again, uh, I'm not that much familiar to create such a strategy, but uh, honestly, I'm not familiar that much with creating such a strategy. So maybe
Yeah,
honestly, I'm not the best person to answer this question. Sorry for that. Maybe
that's,
I answer another questions.
yeah. Sir, there is one
So
more question talking about what are the word embeddings and how are they used in NLP?
Oh, okay. So I see two questions regarding the LLP. So let me start with the first one. What are the words embeddings and how are they used in NLP? So in natural language processing, the when the computer sees the words or the text that we are seeing, the first, like when you have a sentence like today is Saturday, today is it's this is under to computer, these are a series of character, but to humans, today is and today is and Saturday are three different words which each of which has some meanings. So the idea of the embedding in NLP was to create or come up with a vector or a series of numbers that have some meaning. So that's and because the basic idea of the deep learning models are a series of vectors or arrays that could be used for analyzing the data. So this embedding is super useful because instead of having some random numbers which were common previously, now we can have a series of numbers that are useful or meaningful to the computer. So let me give you an example. So assume that you have three words like man, woman, and son. Man, woman, and son, and the another woman like the computer. Okay, so what we can do here is for the man, woman, and son, you can have three different vector or embeddings that are kind of similar to each other, showing that these three concepts from a word perspective are very close to each other. However, when you're looking at something like computer, you have a vector or embedding that's quite different in the values that you're looking at from the other three. So with these vectors or like embedding that we say, we can make the computer to comprehend these data better. So this is the basic idea of the word embedding in NLP that helps the deep learning algorithm or networks to work with the data better and do mathematics on this word. So this is a general ideas, and many of the algorithm that we use, for example, BERT is actually something that gives you a very high quality embeddings for your word. So that's what the BERT does.
Thank you, sir. Thank you.
You're welcome.
Oh,
I
thank
got
you.
another question that do you think
Yeah.
I'm seeing another question that do you think
Yes.
MBA program must be recreated or revisited to prepare students for an AI-driven business arena? So my answer is yes. Honestly, after the AI or the new generative models, uh, nothing is similar to 2 years ago anymore. So we definitely have to revisit our curriculums and make sure that our students, and this is something that we have started in our school, that the curriculum should be revisited, making sure that our students are able to working with these new technologies and use them in their and they are ready to use them in their career in the future. That's the significant milestone. And yes, my answer is yes. It's a very important, it's super important to make sure that we revisit the curriculum, making sure that the students are capable of using this generative AI. Maybe 1 year ago or 2 years ago, many of the universities or companies started to preventing the students and the employees from using such technology. However, even in my classes, I'm encouraging the students to use generative AI. In many cases, my students are not only allowed it but encouraged to use generative AI, making sure that they are capable of using such techniques. So I believe that's a very yes answer to that questions.
Yes, sir. Sir, here we come to end of Q&A session. So I would like to propose word of thanks for this session, sir. We are privileged to have you here, and I personally, and on behalf of my department, we truly appreciate the time that you have taken out to conduct this session for us, sir. We understand how odd timing it is for you there, but still, the session was so interesting with the simple examples that you have taken, and especially even for Q&A session, the examples that you have taken to explain us the word embeddings. It was so good. Thank you so much, sir, for sharing your insight and for such vivid presentation. It was an enlightening session for us, and I'm happy for the scope or the motivation that you have shared, especially about the growth prospects for the MBA students in this domain. Thank you so much, sir.
Thank you so much. It was really an honor to be with you all tonight, today and tonight, and wish you best of luck with your program. And I would be happy to in touch with you. So let me know if you have any further questions. Yeah, but very thank you for organizing such a wonderful event. Thank you so much.
Thank you,
Thank
sir.
you,
Thank you,
sir.
sir. Thank you very much.
Thank you.
I request all the participants, can you please fill the feedback link which we are going to share in the chat box.
Thank you, sir. Thank you so much.
One more announcement for the participants. We have the last session, which is scheduled at 5 p.m. today. You can stay logged in, or you can get back, resume to the meeting sharp by 4:55. Later that, like, we have assessment and then a valedictory session. So please kindly fill the Google form shared in the chat box for this 12th session, and then resume to the last session of this FTP, that is at 5 p.m.
Sir, Venkatramana sir,
Sir,
I
yes,
hope
sir.
I'm audible, right? Loud and clear.
Yes, sir. You are audible, sir.
Okay, thank you. Naresh, are you there?
Yes, sir.
Can you make me co-host?
Okay, sir.
అంటే మన ఆపర్చునిటీ ఉంటేనే చూడు లేకపోతే అవసరం లేదు.
Okay, sir.